Power of a lens. The degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. In other words, we can say the power of a lens is a measure of the degree of convergence or divergence of the light rays falling on it. Here we see a convex lens of shorter focal length bends light rays towards the principal axis through a larger angle by focusing them closer to the optical center. Now, here we see in another diagram a beam of light is incident at a distance h from the optical center O of a convex lens of focal length small f. It converges the beam by angle delta like this. Clearly we have here tan delta is equal to h upon f. We know tan theta is equal to perpendicular upon base. So here we have perpendicular h and base is f here. If we take h is equal to 1, so we get tan lambda is equal to 1 upon f, and we can say tan lambda is equal to p, so p is equal to 1 upon f in meter. The power of a lens is defined as the tangent of the angle by which it converges or diverges a beam of light falling on the unit distance from the optical center. Okay, so what we have learned, the power of a lens may be defined as the reciprocal of its focal length in meter, and we can say p is equal to 1 upon f, or we can say power of a lens is p is equal to 1 upon focal length f in meter, and the SI unit of power of a lens is p is equal to, it is 1 upon m, so it is 1 upon meter, so it is meter inverse, and we can say it is diopter. So the SI unit of power of lens is diopter, and we can express it by capital D. For convex lens, we know that focal length is positive, so when f is positive, so p will positive, so the power of a lens, so the power of a convex lens will positive. Okay, and for concave lens we know that f is negative, so d will negative here. Now we can take some examples here. We know that power of lens p is equal to 1 upon f in meter, or we can say the power of lens is equal to 1 upon focal length in meter. Okay, and we can also say p is equal to 1 upon f 100 upon f in whenever f in centimeter, we can say p is equal to 100 upon f. Okay, now our first numerical is that find the focal length of a lens of power minus 2.0 diopter. What type of lens? We know that the power of lens p is equal to 1 upon focal length f. So put the value of p here. So here p is equal to minus 2. Okay, so minus 2 is equal to 1 upon f, and we can say f is equal to 1 upon minus 2, and it is f is equal to minus 0.5. 1 upon 2 is equal to 0.5, so it is minus 0.5 meter, so we can say f is equal to minus 0.5 meter, or we can say f is equal to 50 centimeter. And the conclusion is that it is concave lens because focal length is negative and the power of a lens is also negative. Now the another example, find the power of a concave lens of focal length 2 meter. So here we have concave lens. We know that the focal length of concave lens is negative. So and we have to find the power of lens. So f is equal to, here the value of f is negative here, so we can say p is equal to 1 upon minus 2 meter. F is focal length is 2 meter here, so f is equal to minus 2 meter, because we know that the concave lens focal length f is negative. So p is equal to here minus 0.5, and the unit of power of lens is diopter, so we can say p is equal to minus 0.5 diopter. And what is diopter? Or the question rise here, define one diopter of power of a lens. So we can say one diopter is the power of lens whose focal length is 1 meter. Okay, and the formula is p is equal to 1 upon f in meter, and one diopter is equal to 1 meter inverse. Thank you.